they say that the ideal state is you have a database per service, but it depends. It's not always possible, specifically for brownfield deployments where you need to kind of have the data shared. So you could have, based on your use cases, you could look at using a shared database, right? And if you really need a very high throughput scalable system, you could look at event sourcing and CQRS, where CQRS is command query responsibility segregation, wherein your writes are different. Your write store is different from a read store, right? So when you write something, you kind of do a create, update, or delete operation from the CRUD methodology of making changes to any entity. You push that data into an event queue, so it basically becomes like an time sliced view of what different operations have happened. This gets stored into event store, and then the handler really kind of pushes them into a data store, right? And think of it that if I'm creating an order, you would have multiple things that happen, right? You kind of process, look into inventory, then you kind of then make payment and all that. So each of them become an event, and that could be pushed into an application data store to say, this is my payment information and this is my orders and all of that. So when you read, that read is from a different data. So this model kind of advocates eventual consistency, right? But this is a very highly scalable model if you really want to do distributed systems at scale. Okay. Then similarly, we talked about the chain micros, how microservices kind of communicate with each other. So three different ways that kind of happens. If you really are one obviously part is each API calls every other API, right? Either through a synchronous call, wait for it, or asynchronous using like reactive frameworks like RxJava or Spring Web Flux, right? And then each of those basically you make a call, wait for the response to come in, you kind of then aggregate all of it together and send that back. The other way is to do that is to kind of really have a message oriented stage management wherein everything. So if you have to place an order, right, I would kind of make a call to the payments API. The payments API will do certain things, and then it will basically say that, okay, payment is confirmed, not confirmed. It will put that into the message queue. Then once if it's confirmed, the order system will pick it up, and then it kind of confirm that the order are done. It pushes it back to the queue. Then the shipping system brings it, picks it up, right? Then it confirms on the shipping, and then it keep messaging back. So based on whether your payment is successful or not, you basically go back over this flow. So this the only challenge with this is some of your contracts are not explicit sometimes, right? So it's harder to kind of correlate it between distributed teams. So the third way for kind of you do the chaining of the microservices is using an event-driven state management, right? Wherein you use an event propagation bus, could be Kafka or could be an MQ like RabbitMQ, but then instead of kind of sending messages, you send events to say that order placed is an event, right? So once it comes to the event queue, it could be a common event queue. The payment system is interested in it, so it picks up that order placed thing. Then it says, okay, make a payment for it, right? It kind of sends that message back, make a payment, which gets picked up by the UI. So that is how it flows. So your event store is a single entity that kind of you can replay whatever happened, right? And asynchronous, everybody can pick up from that common bus and do what they would like to do, right? So this is a fairly mature, stable way of chaining microservices. Again, this is something that the architects and the enterprise architect, the technical architects designing that system would decide on what works best. But this is something where if you really want to do well-designed distributed system, this is where you should go to. Okay. Then you would have an API gateway, right? Kind of, if you look into the APIs, how we want to kind of group them, uh, you would need to have a set of APIs that mimic what the user is trying to do. Like if he's placing an order or he's viewing at a dashboard, the data has to come in a single call and has to come consistently. So you need an experienced API layer that mimics what the user is doing, and then you typically have what we call as two more layers in your APIs, which are called a domain layer. A domain layer basically brings up a single business operation, and it's also responsible for rolling back if that business operation doesn't succeed. So right. So and then you have at the bottom you have a set of system APIs that are very fine-grained API that do only one thing well. and you kind of really kind of call all of them together and compose your next two layers based on that, right? Now, but when you have all of these APIs in front, you need a common layer to front all the APIs, right? So basically, it proxies your request to all the concerned microservices, right? And it can kind of do other things, right? It can kind of act as an aggregator, right, to basically get data from multiple microservices and build it together in parallel or sequence and give it back, right? You could have your API gateway, so that the API gateway provides all of this functionality, right? To kind of give you a single window or a single endpoint to call the services, and it manages the routing to all of this API endpoint, right? So you have different options like software gateways like Zool or Spring Cloud Gateway. That's part of the Spring Cloud framework. Then you could also use commercial third-party tools like Apache or Kong or IBM Cloud Gateway to set up your API gateway. But it takes care of like all the other common concerns like what we call as throttling, right? Or having a common authentication layer. Similarly, if you are making requests from the browser back to the API, you need a cross origin access, right? To for somebody in domain A to make a call to domain B. If your APIs are hosted on a different subdomain or domain than your UI, so all of that is functionality is taken care by the API gateway. So that forms an integration pattern, and we'll look into that in a bit, right?